Hello, my name is Vint Cerf. I'm Google's Chief Internet Evangelist. Today I'd like to talk to you about OpenFlow networking. I wish I could be there in person, but unfortunately my schedule didn't cooperate, so you'll have to put up with virtual Vint. OpenFlow networking is one of many techniques for creating layer 2 structures that could lie below the level of the traditional TCP/IP internet. There have been other technologies that have attempted to create these lower layers. Some of you will remember things like X25, frame relay, asynchronous transfer mode, multi-protocol label switching, and now OpenFlow. But OpenFlow really represents something quite new and different. For one thing, it is able to use bits in each of the packets that are outside the normal range of the address fields of the packets. This creates a level of potential and creative new ways of deciding where packets should go and how they should be routed. We are only just beginning to scratch the surface of that capability. As many of you will know, Google has implemented a version of OpenFlow to run inside of its data centers, providing much more refined control over the flows of traffic inside the data center, enabling much higher percentages of utilization of all of the high-speed connections that link our various computers together. I see, or foresee, many new opportunities both to explore and to experiment with this new kind of networking, and in a way, it is a recurrence of the original internet design. Let me explain. When the internet was first designed in 1973, the networks that it interconnected had an underlying network layer. It wasn't called layer 2 exactly because the layer 2 was link level. The layer above that actually routed packets around inside the ARPANET, inside the packet radio net, inside the packet satellite net. And of course, Ethernet was contemporary with those systems. And there was no routing going on in a traditional Ethernet because it was more or less broadcast. The problem is you had to know what the MAC address was of the destination in order to make sure that that destination would pick up a packet that was intended for it. And so things like address resolution protocol were used in order to make that binding. So in that sense, the Ethernet was itself a kind of layer 2 network. It just didn't have routing in it. When these Ethernets were interconnected in a more elaborate way, routing trees were established, or spanning trees were established in order to create connectivity. And once again, using MAC addresses as a way of identifying the destination. So in a sense, when when the Internet protocol was used exclusively as a way of saying where packets were supposed to go and where they came from, we tended to lose the lower level indirect capability of the layer 2 system to route traffic from one place to another. It gave a flexibility that diminished as we focused so heavily on the IP layer. With the introduction of software-defined networking, and in particular in the form of OpenFlow, we now have regained a substantial degree of flexibility as to how packets are routed in the net, independent in some sense of the IP addresses that guide their ultimate destination. So I'm sure that you're looking forward to a very, very vigorous discussion in the course of this conference. I'm very eager to hear the results, and of course I look forward to seeing what comes out of the Korean initiatives in software-defined networking. So in the meantime, I hope I'll see you on the net.